All right, I think we are live. So, hello everybody, and welcome to the third episode of the New Horizons trilogy. This time it's the countdown to Pluto. For people who aren't aware, we're less than a month away from New Horizons' epic encounter with Pluto, and so we wanted to take everyone's information. We wanted to update everybody on what's going on, take some of your questions. So once again, I'm Fraser Kane from Universe Today, and I am pleased to be joined by Alan Stern, who's working on the primary investigator of the New Horizons project. Hey, Alan.
Hey, Fraser. How's it going today?
Good. I'm super excited for us to finally see images of Pluto. So, can you let us know the team that you have assembled today?
Yeah, absolutely, and you're absolutely right too. We are 25 days from stop number 9 on the tour, the exploration of the planets. So we have 6 people from the New Horizons project, and 5 of us are here at the Applied Physics Laboratory in Maryland, and 1 is back at Southwest Research in Boulder. And why don't we start here in the room, and then we'll go to Boulder, and let each person introduce themselves. As Fraser said, I'm Alan. I'm the principal investigator, or PI, of New Horizons, and we'll start with Kathy Olkin.
Hi, I'm Kathy Olkin. I'm a deputy project scientist on the New Horizons mission.
Hey, I'm Jimmy Lee. I'm the NASA mission manager in the New Frontiers program.
I'm Will Grundy. I'm the lead of the Surface Composition and Chemistry Science Theme Team.
And I'm Kelsey Singer. I'm a postdoc on the mission, and I work with geology and geophysics.
Alex in Boulder.
I'm Alex Parker. I'm a research scientist here at Southwest Research Institute, and have been working with the mission for a while now on finding an object to go to after Pluto, and am helping out as best I can with the actual Pluto encounter.
All right. So for the people who maybe missed the last episode, when last we saw our heroes, New Horizons had just turned on again, had taken some images, but they weren't as good as what Hubble had taken. But now I know that there's been a ton of new images that have been coming back from New Horizons. So Alan, can you give us an update on where the mission is at now?
Yeah, well, as I said, we're 25 days out, and that means that we're around 15 million miles, a little bit further, but close to 15 million miles to Pluto. So we're much closer to Pluto than, for example, the Earth is to the Sun. In fact, we're closer to Pluto now than the Earth approaches any planet. But it's still a long way off, so our images, while better than you can take from the Earth, or even with Big Bad Hubble, because we're closer, still are only starting to show the first details. We can see large regions on the surface of Pluto, and we're starting to be able to see details on the surface of Charon. On Pluto, we've announced that we found what we think is a polar cap, a very bright region up at the North Pole, which is just ubiquitous. That's every face of Pluto shows the same thing. We don't have compositional spectroscopy yet to nail the case, but it's a pretty strong circumstantial case. We're looking for new moons. We're looking for satellites. We haven't found any yet, but we're going to get a lot closer and be even more sensitive. We're finding big dark regions on the surface embedded in this kind of brighter substrate, which we think is ice. We're puzzled by these big regions. They're sort of analogous, and I'm sorry we didn't bring a picture, but they're sort of analogous to if you took a pair of binoculars and looked at the Earth's moon, and you'd see the big mare that form the face of the man in the moon. They're large like that on the disk of Pluto, and we don't know what they're made of or why they're there, whether they're temporary features like where ice is sublimated away to reveal a substrate, or whether they're a coating on top of something, or they could even be some topographic or geological construct that may not be composition related. We'll have to find out by getting closer and getting more instruments on it, but it's certainly getting interesting already.
That's fantastic. So I've got a couple of questions that I was going to ask, but I just want to remind people who are watching this that this is actually a live, interactive conversation. So if you want to join the conversation, wherever you're watching this on YouTube, just click the link that says that we're interacting with the audience, and you'll open up the Q&A app, and then you can post some questions, and I will take a look at the questions there, and I will pose them to the crowd here once a few questions have gathered together. So I think I'd love to know as well about some of the moons that you've seen. I know that they've had some strange kind of tumbling orbits. Can you give some more information on that?
Yeah, there's a recent paper that was just published in Nature by Mark Showalter, who's a member of our science team, and Doug Hamilton, who's a professor at the University of Maryland, both experts in planetary dynamics. And Alex, would you like to take a crack at a brief summary of the results?
Sure. So the small satellites Pluto, I mean, we've only known about them for about a decade now. They were discovered. We've known about the largest moon of the Pluto system for many decades. That's Charon, and that's the moon that's large enough to actually drag the balance point outside of Pluto itself. So if you look at the Pluto system and watch it through an entire Charon orbit, Pluto actually orbits around an empty spot in space, and Charon also orbits around that. It's called the system barycenter. So we've known about Charon for a long time, known that there's sort of a double planet system, but then about a decade ago, we started finding these smaller moons further out in the system, Kerberos, Styx, Nix, Hydra, and they form this really compact system of small satellites orbiting around a binary planet. So it's a really complicated system. You're packing these things in very close to this massive duet going around that's driving them in kind of fascinating ways. And so these guys are really faint, they're really hard to see, and it takes really careful measurements to be able to detect their influence on one another. And so for a long time, we've been trying to understand just how coupled they are, how much each satellite affects the other satellites, how much the presence of that Charon-Pluto double planet affects the orbits of the satellites. And one of the things that's recently become sort of possible to think about is actually thinking about not only the orbits of these small satellites, but the spin states, how they're rotating. And so what Mark did was he looked at their light curves, how bright they are as a function of time, and basically showed that you can't take any one rotational period and apply it for very long. It looks like the satellites tumble and change the rotation rate as a function of time, kind of chaotically. And what's really happening is that they're all buried in this system with this massive binary planet in the middle that's perturbing them in these really complex ways, and it's causing them to tumble in their orbits as opposed to having a nice stable rotation like we're used to here on the Earth and most of the other planets. So there's a lot of really fascinating interactions going on in the Pluto system between all the different satellites and both their orbits and their spins. And this system, I mean, even when we had just bare, sketches of an idea of what the system looked like, it was a real challenge to figure out where it came from and how it could exist in the sort of state that it's in. And it's getting more and more complex as time goes on. It's becoming a bigger and bigger challenge for people to try to figure out the origin and evolution of this system. So it's really exciting to get this kind of data and to look forward to the kind of data that we're getting with New Horizons as we fly through to try to understand the origin of this complexity.
Yeah, and it's just beginning. I mean, the pictures are going to get better, the data is going to get better. It's pretty exciting. How is the health of the spacecraft?
Jimmy?
Well, right now the spacecraft is really healthy. We just performed a correction maneuver to just keep us on, going toward the target. That was performed on June 14th, and everything went as planned there, and we're on course there for the planet, and all the subsystems are reporting nominal conditions at this point.
It's fantastic. And so for the, if people want to know what are some of the highlights that are going to be coming up over the next couple of weeks, what are some dates, some important events that are going to happen between now and the actual encounter?
Okay, well, Kathy, you want to take a crack at that?
Sure, I'll answer that one. Right now, the New Horizons spacecraft is taking images in color of the Pluto system on a daily cadence, and so that will be downlinked later, and we'll get a look at those images. We're also this week taking our first infrared spectra of Charon. This is really a pathfinder, a first observation in the infrared from New Horizons of Pluto and its largest moon, Charon, and we'll be looking at that data, and it's really a warm-up from when we're near closest approach and getting our best, highest resolution data. We continue data with the LORI instrument, which is a panchromatic camera. It's like a C8, like an 8-inch telescope inside the New Horizons spacecraft, and the plasma suite is continuing to take observations. So there's a lot of things going on, and those results will be coming out as we get them down on the ground.
So I know that the last couple of times that we had this hangout, one of the concerns ahead was what kind of debris, what kind of maybe smaller moons, other objects there might be around Pluto, and there's some concern about, is New Horizons going to be able to make a nice, safe passage past the dwarf planet? So, have you seen any idea, any possible hazards ahead, or is it, smooth sailing?
Well, we've been working on that pretty intensively. I think in the second installment, we called this period of time when we're doing the hazard searches 7 weeks of suspense. We started in middle of May, and we'll conclude just before July 4th with that search. And we're doing about a search a week with very intensive imaging by that LORRI camera that Kathy was just talking about, making very deep time integrations to look for faint objects in the system. We've now completed 3 searches, each successively closer, which makes us more sensitive to smaller and smaller objects. And it also, as Pluto and the satellites grow in the windshield, it lets us look more closely, particularly in the area between Pluto and Charon, where there isn't a whole lot of space, but that's right where the spacecraft is going. So we're very interested in that area. And I can tell you that so far we found no moons, no rings, no danger, all clear.
Well,
Got a couple more weeks to go, and we'll see if we find moons. Finding a moon, by the way, or even several moons, doesn't necessarily mean it's dangerous. It depends upon where they orbit and their sizes. So from a scientific standpoint, we could end up in a sweet spot of finding more moons, more things to study, more clues about the origin of the Pluto system, and yet have no measurable danger whatsoever.
That's excellent. So I'm going to take some questions from the audience now. Let's start with, this question comes from Adam Synergy. Will New Horizons get a chance to image all of Pluto and Charon's surfaces during its flyby?
Well, Kelsey put together those playbooks, so she'd be good at this one.
Sure, yeah. So unfortunately, we won't get to see the surface of both Pluto and Charon, but we will do our very best to get as much as we can. So when we're flying by very quickly, and so only one side of Pluto will be the highest resolution. And so we'll get the other hemispheres of Pluto as we're flying in, and we'll get those at variable resolution as we are even getting them now. But only one side will be the very highest resolution because that will be the lit hemisphere. And as we fly by, actually, we'll try to look back at the dark or unilluminated hemisphere of Pluto and try and image that with Charon shine, which means that's light that's reflecting off of Charon back at Pluto. So we'll really try to get the whole surface, and we will get the whole surface at different resolutions, but the very highest for Pluto and Charon will be of one hemisphere.
Can you say a little something about how we'll do on the small moons?
Sure, yeah. So the smaller moons will be in various places around Pluto and Charon. The one that will be closest to us as we fly by will be Nix, and then we'll get about 300 meters per pixel on Nix, and then it'll be less on the others because they'll be a little farther away.
Excellent. So this question comes from Mary Alvarez. Based on what you already know from the other planets and their moons in our solar system, what do you expect to find in the Pluto system?
Well, I think different scientists, different members of the project each have their own opinions about that. So why don't we, if you've got the time, we could just go around the circle and let each and every one of us say a word or two about what we
That sounds great.
Okay, Kathy?
It's interesting because we've never seen a Kuiper Belt object up close before. This is really the initial reconnaissance of this part of the solar system. And so we don't know what to expect. I do a lot of ground-based observing where I look from telescopes on the Earth and observe Pluto. So what I'm really interested in is the composition of the surface, different ices and where they're located, and just understanding that in a level of detail that we've never seen before. So I'm hesitant to even say what I think we might see, but I can't wait to see it.
Yeah, as Kathy said, it's we don't really know, but I think we'll get a better handle on the surface composition and geology, and so I think we're just uncover a lot of those mysteries with this flyby.
I'm interested to look for things with motion. I'm interested to know if we'll find clouds, for example, in the atmosphere, discrete clouds. I'm interested to know if the atmosphere of Pluto transfers over to Charon, as some models predict. I'm interested to know if Charon shows surface activity, or for that matter, if we see activity on the surface of Pluto. So those are some of my highlights in terms of what I'll be looking out for. Bill?
Yeah, so a proxy for the Pluto system that many of us have in our minds is Neptune's large moon Triton. And the reason for that is it's about the same size as Pluto, a lot of the same surface ingredients, nitrogen ice, methane ice, carbon monoxide ice, and so on. And
it used to orbit in the Kuiper Belt.
Yeah, and in fact, it's probably a captured object very similar to Pluto. However, the environment that Triton inhabits now, a retrograde orbit around Neptune, is very, very different than the dynamical environment that Pluto's in. So I wouldn't go out on a limb and say it's going to look just like Triton. It's not. But it may have many common features with Triton. And Triton has a lot of interesting features. It's got geysers erupting from its surface. It's got seasonal mobile ices that migrate from one hemisphere to the next. A lot of processes that are sort of weird and exotic are going on Triton, and I hope we see some of those same processes and maybe some new ones on Pluto.
Kels?
Yeah, so I'm going to pick up of what Will said and say I'm excited to see features that we've never seen before, because there's going to be some unique features that are created by the combination of processes that are going on on Pluto and in Pluto. And also I'm excited to see some features that we are familiar, because it's really helpful to compare those features we see on Pluto, which is an icy surface with maybe some interesting ices, to those same features that we see elsewhere. For example, I work on cratering, so they may just seem like holes in the ground, but they are actually really interesting, and they can tell you about the surface that they're made in and all sorts of things. So I'm interested in both the familiar and unfamiliar features.
Okay, Anchor Leg, Alex, and Boulder.
I was getting a bit of echo earlier, so I'm hoping this is better now. I'm going to have to second Kelsey on the cratering. Particularly, I'm interested in seeing what the surface of Charon looks like and how beat up it is. I've spent most of my career studying the Kuiper Belt from the perspective of trying to understand its growth, history, and evolution. And one of the big hanging questions is just how many small objects are out there. They're basically impossible to see directly. There are some clever observational approaches you can use to try to get a handle on them, but those have been challenging to date. And one of the best tracers for small objects is looking at the holes in the ground they make when they smack into things. So if you can look at Charon, which we think is probably a lot less active than Pluto, so Pluto might have processes occurring on its surface that are erasing old craters, but we think those are going to be occurring, if they're occurring at all, occurring more slowly on Charon. And so you can use Charon's surface as a better indicator of the history of impact in the Pluto system, and from that back out maybe something about the very small objects in the Kuiper Belt. And those small objects are really powerful tracers of the mechanisms of planet growth information and evolution. And so if you have a relative small number of small craters or a relatively large number, you're learning a lot about fundamentally how planets formed.
One of the things that has been sort of in the news quite a bit now is this sort of the discovery of these various ice geysers, water ice geysers. They're finding them on Enceladus. Potentially there's some strange features on Ceres. We're not really sure what they are yet. Do you think that there might be some kind of activity on Pluto? I mean, Alan, I know you were talking about hopefully seeing something changing. Do you think there might be something like that on Pluto?
Yeah, I'll speak for myself, but this is an open scientific debate, at least for the next 3 or 4 weeks. And others can chip in. We have definitely planned to look at a high resolution for evidence of activity in the form of geysers, both on Pluto and Charon. There's some evidence in the form of crystalline water ice, which maybe shouldn't be there on Charon unless it's very recently in place, and some evidence for ammoniated hydrates that could be evidence of activity on Charon as well. So we're going to look on Charon and on Pluto about equally well at the same kinds of high resolution, and we're going to take advantage of looking back at both worlds after we pass in a special observing geometry that lets us see fine particles called forward scattering geometry. And this is the same technique by which the Enceladus geysers were first discovered, by looking the same way, sort of back towards the sun, where the particles brighten up because of the way that they scatter light. It's a very sensitive technique for looking for rings, but also lets you look for hazes in atmospheres and for fine particulates that are coming out of volcanoes or geysers. So there are going to be a lot of ways to look for evidence of this activity, and we don't have to wait very long. Middle of July is coming.
I like that you've got a scientific question that's only going to last for about another 3 more weeks. Everyone could just stop arguing right now and just do something else, and then we can argue later. Okay, so speaking, you talked a bit about the atmosphere. Question from Pedro Braganca. How does Pluto's atmosphere so far compare to the other planets that have been previously studied? And I'd be interested to sort of add on top of that, any evidence that perhaps its atmosphere has frozen and kind of collected on the surface, or, what's the state of that?
Yeah, so I'll start off with the very big picture, but Kathy Elkin, her expertise is actually in this observation and modeling of Pluto's atmosphere. She's done a lot of work with stellar occultations. She's done a lot of modeling that addresses the specific question that Pedro just asked. But, of course, Pluto's atmosphere is very different from the atmospheres of the giant planets. It's a much more rarefied atmosphere on a much smaller planet. In fact, Pluto's atmosphere is much more rarefied than the atmospheres of 3 of the 4 terrestrial planets. It's much thinner and therefore less dense than Earth's atmosphere, Venus's atmosphere, and Mars's atmosphere, but it's much more dense than Mercury's atmosphere. It forms a kind of middle ground, a lot like the high upper atmosphere of the Earth called the mesosphere, where there are clouds and where global change can take place and other phenomena. And this is a similar temperature and pressure region, and it's made of the same stuff, primarily nitrogen, as the Earth's atmosphere. A good analog to Pluto's atmosphere is probably what Will was talking about at Triton, where there's also a nitrogen atmosphere with similar densities. And the other part of the question was about whether Pluto's atmosphere freezes out or not as Pluto moves around its orbit. Kathy's one of the world's experts.
Let me just jump in
Sure.
with one thing, though. Like Alan said, it's dominated by nitrogen, and nitrogen also exists as ice on the surface. And there is far, far more nitrogen on the surface than there is in the atmosphere. So in a sense, it's already frozen out, but there's still an atmosphere left above it. So just to get you oriented, most of the atmosphere or most of the nitrogen is on the ground.
That's analogous to the Earth, where most of the water is in the oceans, but a little bit is as humidity in the atmosphere.
That's right. Yeah, and so the atmosphere of Pluto is about 100,000 times less dense than Earth's atmosphere. And we can observe the atmosphere of Pluto by watching as Pluto passes in front of stars, and the starlight dims out. And how the starlight dims out tells us about the pressure and temperature in Pluto's atmosphere. This technique has been used since 1988 to study the atmosphere of Pluto. So there was a measurement in 1988, and then later in 2002, and then moving forward in about 2006 and on, we had annual observations of this. And what's really fascinating to me is that Pluto's atmosphere doubled in pressure between 1988 and 2002. Think of that. That'd be just amazing if it happened here on Earth. We don't get anything like that for pressure changes. Of course, we have a lot more atmosphere. But anyways, Pluto is a really dynamic and changing world. And this has to do with the sunlight on the ices. And by looking at a number of time periods and seeing what the atmosphere is doing, we're able to see how the subsurface holds on to its heat. And then that was the subject of a paper that colleagues and I wrote recently. And what we said was that it looks from the evidence that unlikely that Pluto's atmosphere would collapse as Pluto goes all the way around its orbit in 248 years. Pluto has a very eccentric orbit, and so part of the year it passed its closest distance to the Sun in 1989, so we're still kind of on the close side to the Sun. But as it goes further and further away, the idea was that the atmosphere would collapse. But if the subsurface can hold on to some of that heat, it will be continuing to supply heat to the ices and support the atmosphere. So it's a really interesting debate. I can't wait for New Horizons to get there because we've got great experiments on board. We have a solar occultation by the ALICE instrument, and that's when we get to look at the ultraviolet light and watch the sun set behind Pluto and then rise on the other side. And by doing this, we're going to learn about the composition of Pluto's atmosphere. This is a measurement we can't do any other way. We're also going to do the same thing watching the Earth set. And the Deep Space Network has these large antennas in Spain and Australia and California. And the antennas will be sending a signal out to Pluto as the Earth passes behind Pluto. And we'll watch those signals be cut off by the atmosphere and learn very accurately what the surface pressure is. And I just can't wait to see this data.
Right. I guess we've never had a chance to see Pluto occult the sun before. So
That's right.
Now the geometry is going to be in your favor.
Right.
So I got a quick question that came from Twitter. This came from Tidal Wave, or Tilde Wave, which is, could there be outgassing accretion exchange going between Pluto and Charon, or something similar to the Phoebe ring? So, is there any kind of interaction beyond gravity between Pluto and its largest moon?
Well, we're going to find out, aren't we? There's a large body of literature by atmospheric modelers going back to the late 1980s. Show that atmospheric molecules and atoms, for that matter, that are escaping Pluto's atmosphere, they have to pass the orbit of Charon. And much like a binary star system, Charon's gravity can pull some of that atmospheric gas into orbit around itself or even onto the surface of Charon and create a secondary atmosphere around Charon, which we have a very sensitive way to detect if it's there, using the same kind of occultation of the sun that Kathy spoke about for Pluto, but which will occur a few hours later for Charon on flyby day, which we'll observe with the same instrument, the ALICE ultraviolet spectrometer. So we are on the lookout for that. The questioner is right on point asking, because this would be fantastic if we discovered something like this. Never in the history of planetary exploration have we seen two bodies with a shared atmosphere like we may see at the Pluto system. It could be quite a wonderland.
You mentioned the Phoebe ring, and so dust is another component that is potentially shared within the system. If you knock small dust particles off of any of the small moons where they escape quite easily, they're trapped in a deeper gravity well that's dominated by Pluto's mass, and eventually they get swept up by other satellites or by Pluto. And Simon Porter, who's a postdoc on the project and earlier was a grad student working with me, did a paper on that very recently, just tracking where those dust particles end up in the system. And maybe we'll see some patterns as a result of that process as well, where certain areas on the surfaces of Pluto and Charon tend to sweep up the dust particles from the outer satellites.
Yeah, like I said, I thought it was just a great question when I saw it. So this one comes from Rohit Gibson. Are there any plans for an extended mission after the flyby of Pluto? And I know we've talked about that there definitely are plans. So have you got some candidate targets that you're going to go to after Pluto?
Yeah, so we do have candidates. Alex has worked on this. The choice of what candidate we'll finally choose is going to be NASA's, and that's a decision that we'll make with them in August. But Alex can give you the lowdown on what we might be able to do.
Yeah, so there had always been kind of baked into the idea of the New Horizons mission this plan for, we don't have in this sort of mission architecture the idea of doing a fast Pluto mission that gets there in a reasonable amount of time, any way to stop the spacecraft at Pluto comfortably. You could stop it. Hang on, I'm getting an echo again. You guys hearing that?
Litho breaking.
No echo.
Yeah, you can litho break, but I'd rather not do that. If you wanted to stop it another way, you'd have to carry along basically as big a rocket as what we sent up New Horizons with. Carry that along with you, and that becomes prohibitively expensive. I don't think that's within the purview of the New Frontiers program. So instead, you do a fast flyby. You do one of these quick first looks, and that means that we're going to carry on out far beyond Pluto and enter the Kuiper Belt proper. So a few years ago, we started a search in earnest to try to find something we could send New Horizons to after Pluto. We're limited by the fact that the amount of fuel that New Horizons has on board can alter its trajectory by about 1/2 degree. So it's a pretty narrow cone going out into the outer solar system that we can explore. We didn't actually know ahead of time of any Kuiper Belt objects that lived in that cone. So we went to some of the biggest telescopes on Earth and the best sites on Earth, and spent over 4 years doing a strategic survey of the area to try to find something that we could get to. And we found a lot of Kuiper Belt objects, some very small ones. We're learning a lot about the Kuiper Belt itself from these surveys. But in the end, we couldn't find any that New Horizons could reach from the ground. So last year, we went to the Hubble Space Telescope. This was Hubble is the most sensitive, but it has a relatively small field of view, so it takes a long time to tile out the area of sky that we needed to search. So we didn't want to do that any sooner than we had to, because if you go earlier, the area of sky that you have to search is much larger, as this sort of swarm of objects that eventually collapse into this cone that we can visit is more spread out further back in time you go. So last year we proposed to the Hubble Space Telescope's committee and asked for some time to do this, and they awarded us the time. It was a really unusual Hubble program, the way it was run. Most of the time, when you win this sort of time, there's a long lag time before your observations execute. When we won the time, I learned about winning the time on Friday. The first data from the program hit the ground on Sunday, so I had to be on an airplane the next day, and I didn't know that we were going to win this, so I had to go buy a plane ticket the second I learned that I wanted to get out here and work with the rest of the team to process this. And then there was this massive time pressure to turn this around, because we had to demonstrate that this program would work. So we had this small amount of time to take a small subset of data and do this survey really quickly to show that we're finding the number of Kuiper Belt objects we expect. And so we had to turn around this survey extremely fast, faster than anyone's ever done a moving object survey with Hubble before, and we did it. So we ran the whole survey through, and we found a number of objects that, with the preliminary data, looked like they were targetable by New Horizons. So we followed those up later and measured their orbits better and better, and confirmed that 2 of them were within the fuel budget that we had allocated to us for the extended mission concept. We've been calling these PT1 and PT3. We recently submitted them to the Minor Planet Center, and so they have Minor Planet Center designations. PT1 is 2014 MU69, for example. And eventually, as we measure these orbits well enough, as we spend more time working on this, we will actually be able to give them proper names, but that's a while yet from now. We have to have their orbits measured extremely well before we're allowed to propose names for them. But that should be in the next few years. So what we're doing right now, we have these 2 targets, PT1 and PT3, that we're following up with Hubble. We're measuring their orbits better and better, and we're running through sort of scenarios of how we think an extended mission might actually go. Because we'd like to go to one of these and fly very close, within a few tens of thousands of kilometers, get close-up images of the surface, map the surface, get compositional information across the surface, look for any kind of evidence of outgassing. We've never seen one of these bodies up close before. We really don't know what they look like. They're probably some of the most primitive objects in the solar system, the least thermally processed objects in the solar system. So, these are totally new territory, and we don't really know what to expect. So we're going to go in expecting and trying to see everything that we possibly can. But as we fly there, there's lots of these other Kuiper Belt objects that we discovered that aren't quite close enough. And we can do long-range observations of those and study things like phase curves and whether or not they have binary companions. So we're building that into our model of kind of what we think an extended mission might look like, and seeing whether or not we can fit all that into our fuel budget and time and communication budget, and exploring those options. So later this summer we'll be getting more Hubble data, and we'll be making a decision sometime in probably August timescale which of the PT1 or PT3 we could fly to, and then come October, that will be the first opportunity that we could actually light up New Horizons engines and retarget to fly by one of these things. And if we do fly by one of them, it'll be in early 2019. So that's the sort of time scale for getting from Pluto to one of these more distant objects.
Okay, great. So I've got another question that comes from Fernando Melendez Gomez, and this is, how do you plan for New Horizons to be able to image such different albedo areas at the tremendous speed that you'll be passing by? How do you plan to focus on the brighter spots, the darker spots, and how is the spacecraft able to switch? And I think, correct me if I'm wrong, but you're going very quickly. And, there's got to be some pretty clever engineering that's going on here to be able to capture images, especially at your closest point where you're very close and the terrain is really rushing past the spacecraft. So I'd love to know sort of what that's going to be like and how difficult a challenge this is going to be to get good imagery.
We're going to get great imagery. In fact, we designed the payload for exactly the flyby that we're on. And one of the attributes of all the cameras that we're using is that they have a lot of a certain quality called dynamic range. What that means is that when they take data, each pixel has a deep well and many subdivisions within it, so that we can see both very dark things at low count levels and very bright things at high count levels. And that attribute was specifically designed into the cameras because we knew that Pluto was contrasty, and we were likely to see exactly what we're seeing already in these first images that are coming to the ground, which is a mixture of very bright and very dark terrains. Now, there's more to imaging the Pluto system than just that, because we are going by very fast, and we have to divide our attention between different targets, and Pluto's moving at the same time the spacecraft is moving. So we also have to compensate for those motions to freeze the imagery. Otherwise, it would smear a little bit, and that would reduce our resolution. So that's all been thought through. Kathy Olkins played a big role in designing those observations, and she's holding a little model here, and she's going to show you how it works.
Right. So there was a lot of amazing engineering that went into designing the spacecraft, the guidance and control system. We can point really accurately. And so we can point to just a very, very, very small fraction of a degree. And we can scan the spacecraft across a target at 34 microradians per second. A microradian is a millionth of a radian. And so this is very accurate.
And what's a radian?
And a radian is about 57 degrees, which Will is demonstrating there. And so another thing we did was we co-located the bore site of our instruments. You can see that also in this model, but here I'll show you. This is a 3D printed model, and the file to make this is available online if you'd like to print one yourself. But this is the Lori instrument here, and then the Ralph instrument and the Alice instrument. Yeah, and they all point in this direction. So when we're flying past Pluto, if Kelsey is Pluto, we can take data as we scan by, as we fly by. And so we can take data simultaneously from multiple instruments. And we're planning on doing that with the Ralph instrument. We're going to get data of all of Pluto. We've designed the field of view of the camera. It's 5.7 degrees, so and Pluto will fill that as we're flying by. So we'll get the whole illuminated face of Pluto at closest approach. And during the same time, our high-resolution camera, the Lori camera, will be taking little postage stamps as we go across
high magnification.
At high magnification. So we'll have observations that are at 70 meters per pixel. So that's like better than a half a football field. If you took like buildings like the one we're in now and could transport them to Pluto, we'd be able to see the shape of the building and see how many buildings there are. So we're going to get really high resolution, high detailed imagery across a lot of Pluto, and then larger context imagery of everything, still at better than a half a kilometer per pixel. So this is going to be really exciting. And these instruments were designed to work together. And to me, the really remarkable thing is the ability of the spacecraft to point so accurately. And I've been so impressed working with the engineers here at the Applied Physics Lab.
It's probably worth noting that these instruments are designed for Pluto, where the light level from the sun is about a factor of 1,000 less than it is at Earth. So they're very sensitive cameras. In fact, we really, that was hammered home when we did the Jupiter flyby in 2007. And Jupiter's 5 times further away from the sun than Earth is, so the light level is down by a factor of 25. And still, most of the targets in the Jupiter system were so bright that it was too bright for us. And one virtue of having very sensitive cameras is that you can take very, very short exposure times. And the very short exposure times also help to freeze any smearing that there could be in the system.
Can we have one more thing?
Oh, sure, yeah, go ahead.
Kelsey's got a point.
Actually, I was going to say Alex and another colleague, postdoc on the mission, put together this great website called Pluto Time. So maybe Alex wants to say something about it. Alex?
So you again? Yeah, sorry. Just trying to keep echoes down. Yeah, so we put together, we had this idea sometime last fall that it should be possible to calculate for any location on the Earth when the local lighting conditions matches those of Pluto around noontime on Pluto. And so, you know, it's about 1,000 times fainter than it is here. That sounds like a lot, but your eyes are very well, you know, are very good at adapting to different light conditions. So in fact, the lighting level in this room that I'm in right now, the internal lighting, right, as you know, when you're inside and it feels comfortable, if you step outside on a bright sunny day, you know, you're immediately blinded. But when you're in the room, it feels perfectly like you can read, it's perfectly well lit. This is probably, I'd have to check, but this room is probably lit right around the surface level of Pluto illumination. So we created this tool that we are calling Pluto Time, where you can go and you basically put in a location, and it will tell you, based on that location and assuming that it's clear sky, the next time that the sun has set sufficiently for the lighting conditions to match those of Pluto. So you can go out and kind of experience the world as if you were on Pluto in terms of how well lit it is. And you'll find that you can go out and you can read a book perfectly comfortably. It's not like a totally dark and dim place. It's actually, you know, compared to sort of human levels of lighting, perfectly reasonable.
Yeah, I think it was 9:35 for me on Vancouver Island. So I actually I took the test and was able to go out and see it and share.
So were
my
you
Pluto
surprised,
time.
Fraser, by just how illuminated it actually is on Pluto?
Yeah, absolutely. How bright it was still. I thought it would have been a lot dimmer, but in fact it was actually pretty bright.
The human eye is a pretty sensitive photon detector as well.
Yeah, absolutely. So I've got another question from Twitter, and this one comes from Explorer. And quickly, please ask what Pluto's core is made of. So, you know, do we know anything about Pluto's core? And as we do the flyby, is there anything that we're going to be able to do that will give us any kind of hint of what it is? And, you know, I know that one of the interesting pieces of research out there is that maybe some of these Kuiper Belt objects have a certain amount of liquid inside of them, right?
Yeah, so, and Pluto may as well. Pluto may well have what's called a perched ocean beneath its ices, an ocean of water. But at its core, that's a different matter. So what we know is a little bit about Pluto's interior. We have a first-order estimate of Pluto's bulk density, which comes from knowing the size and therefore the volume, and measuring the mass by using the satellites and Kepler's law to derive Pluto's mass. And from the ratio of those two things, we found out that Pluto's density is a little less than twice the density of water, which indicates it's a mixture of ice and rock. Precisely what its density is requires knowing its radius better than we've been able to determine from the Earth. We've been uncertain about the radius because of complicated details at the level of a few percent, at the level of tens of kilometers. Out of a 2,400 kilometer diameter, it could shrink or it could expand based on New Horizons data. I mean, the planet won't change, but our knowledge will, by tens of kilometers. It could go a little bit up, go a little bit down. If it goes down, that makes the planet overall denser because we have the same amount of mass being squeezed into a smaller volume. The radius is bigger than we thought, then just the reverse happens. You have more volume to spread that mass out in. The net result would be a higher ice fraction. So with New Horizons, we're going to shed light on that bulk density by measuring the radius accurately. We're also going to get an even finer knowledge of the mass from radio tracking. And then to actually probe the interior, we have a couple different techniques. I'm going to ask Kelsey to chip in on part of it, which is what we can tell from the geology of the surface and the shape of the surface that could tell us about the deep interior. But in addition, we'll be able to make much better models, which will be informed by a whole variety of different data sets we'll get, not just the topography and the geology, but also even thermal measurements that could tell us about hotspots and how heat is escaping how much is bottled up in the planet. One of the things I'm most interested in is whether or not the planet is a kind of jumbled mixture in its interior, or whether it's more like the Earth and is layered with an actual distinct core of the densest materials at the center, and then a mantle of intermediate density materials, and then a crust of the lightest materials that floated to the top long ago when the planet was liquid. And we can determine some information about that from precise radio tracking of the spacecraft that'll tell us about the moment of inertia of the planet, and that will tell us in turn about how layered or unlayered it is. And so I'd really like to know if Pluto actually has a distinct core, and that measurement will tell us about it. As I said, we can also, from the imagery of the geology and by looking at full disk images that show us the very precise shape and how it deviates from a perfect sphere, we can learn more. And Kelsey is an expert in this, so she can take
Sure.
it.
Yeah, so some of you may know that the Earth is not exactly spherical. It's just a little bit squished. And so the equator is just a little bit wider than the poles. And so if we see this same kind of effect on Pluto, that'll tell us something about how the interior materials are responding and something about how they're distributed, like Alan was talking about, whether they're condensed more in the middle or if they're just more mixed up, the different materials. And also, it could potentially tell us something about whether there's this subsurface ocean that Alan mentioned. So even though the shape maybe doesn't seem that exciting at first, it actually can tell us all sorts of things about the interior. And then, of course, there's the fun geologic features that Alan mentioned. Some of you may be familiar with some of the moons of Jupiter, like Europa, which also has a subsurface ocean under an outer icy shell, and that creates really unique geology there. And so that's part of the reason we have known that there is an ocean under the ice shell on Europa. Other reasons come from measurements from different instruments, but the surface geology really lends itself to telling us about the interior as well. The craters look different on Europa compared to the neighboring moon. There's all sorts of really unique features like broken up ice regions. We don't necessarily think we'll see the same features on Pluto, but we might see other features that really can't be formed unless there's a subsurface ocean. So that'll really help us understand the interior as well.
It's like another place to search for life in a subsurface ocean. But that'll have to be a future spacecraft. So this next question comes from Tracy Dillon, which is, I'm a school teacher. Many of my students ask me the importance of exploring Pluto. So could you talk about that?
Yeah, I think that a lot of us can chip in on this question because there are a lot of different reasons that it's important. It's important to explore and develop new knowledge. It's important from a scientific standpoint. It's also important because her school children should see something they've never seen before, which is a point of light become a real place that human beings know about. And that's an opportunity to excite kids to STEM careers. It's a chance to teach about the real scientific method actually happening before your very eyes as discoveries are made, new data is debated to determine what it means, things like that. Let me toss this out for anybody that wants to answer, and then when we get towards the end, I'll just mention my own best scientific motivation if it hasn't already come up. So who wants to jump in?
Well, I can target one piece of that, and I'm going to intentionally leave quite a few other pieces on the table because there really are a lot. But one thing that many of us are excited about is the origins. And in order to understand the origins, you really have to understand the processes that are at work today. The processes themselves are very interesting and probably quite novel and exotic. But you've got to understand those processes before you can even begin to run the clock backwards and say what the starting conditions were. And so that's one piece of it. I'll leave the rest on the table.
Well, I'd like to say one thing about going to Pluto and the Kuiper Belt. It's an area of the solar system we've never been before. It's the third zone of the solar system, and we've explored what's near to us. The Earth, the Mercury, Mars and Venus, the terrestrial, the rocky planets, the big giant gaseous planets like Jupiter and Neptune. But this third region of the solar system, we don't know a whole lot about it. So it's really, it's a lot. It's something we're going to unlock that mystery or whatever,
This
and
is the
learn a
first
lot.
mission there?
Yes, first mission to this region of our solar system. So I think we'll learn a lot. It's exciting.
Yeah,
Yeah.
I agree, Jimmy. That's a really strong interest of mine, is to understand that third zone. But also, I started studying Pluto when I was a graduate student studying planetary astronomy. Pluto was an astronomer's planet. No before. And there were lots of interesting measurements to make and things to learn. And I'm just very excited that we are going to transform, as Alan said, this point of light into a world that you can see the surface and really know what it looks like. And I think that's just hugely transformative. And to be working on this project at this time, it's just so very exciting.
Anybody else?
Can I do another one?
Sure.
Because I left this one on the table in case anyone would grab it, and nobody did. So one thing that I think is very exciting is Alex talked about the small Kuiper belt objects. These are really the native planetesimals that first formed very quickly from the dust and gas in the outer planetary nebula. And then you start accreting them together and building up much larger objects. Pluto is sort of the next step on the way towards building places like Neptune or Uranus, where you build it up so big that it starts grabbing a massive gaseous atmosphere.
Neptune and Uranus were once Pluto size, on
yeah,
the way to
yeah, on the way up.
Today.
And so with this mission, we're going to see the bricks, we're going to see a small house, and we've already seen, the giant convention center. So it's really neat that we get to see all of these steps along the way to building what's in the outer solar system.
Yeah, and I'll chip in two things that are a little counterintuitive about what we can learn about the Earth from the Pluto system. One is that all the models indicate, and we'll see if they're right, but there's pretty good evidence that the Pluto system of moons was formed the same way that the Earth-Moon system was formed, through a giant impact. Nowhere else in the solar system have we been able to go up close and personal and study an analogous system, the formation of the Earth-Moon. And this is going to be very important. I think it's going to teach us a lot about how to model the formation of the Earth-Moon. It's a little counterintuitive that you have to go all the way to the other end of the line, to the frontier of the solar system, 3 billion miles away, to learn about our Earth. But there's actually a second reason that Pluto can teach us about the origin of the Earth, and that is that Pluto's atmosphere is rapidly escaping, in part because the atmosphere is hot, and in part because the gravity is low. And the escape process that we think has taken place there is one that's never been observed at any planet. It's only been predicted by theorists and modelers. It has a fancy name called hydrodynamic escape, and it means that the bulk of the atoms and molecules in the atmosphere can escape when they get high enough up to where they have a clear shot to get out into space. And the interesting thing is, that's exactly the process that was taking place on the young Earth, when the Earth was hot from its accretion, and the surface was molten, and the atmosphere was very hot and distended. But we've never been able to go to a place to see how hydrodynamic escape actually works. Turns out Pluto is our only opportunity in the solar system to see this in action. And so in a way, a mission to Pluto, like New Horizons, is a chance to travel back in time and see what the Earth was like immediately after it was formed, when it had this poisonous hydrogen-helium atmosphere that no life could breathe, that it lost in order to make room, if you will, for the comfy nitrogen-dominated atmosphere that we have here today.
All right, so I hope the kids were able to get all that and get all that down. That should keep them busy for their whole
quiz
careers.
on part 4.
Yeah, exactly. Well, there better be a part 4.
I was just going to say, too, that I haven't been working on the mission quite as long as some of these people, but I'm already tired of saying that we don't know what Pluto looks like. So I'm really excited that I don't have to say that anymore.
Not for long.
And, kids, growing up won't have to say that either. They'll know what Pluto looks like as well.
Yeah. So I've seen this. We've got about 5 minutes left, so I want to start to wrap things up. But I've seen the same question put up a bunch of times, and I think this is sort of a good segue, which is, over the next couple of weeks, there's going to be more and more data starting to come from New Horizons. There's going to be a lot of places, a lot of pictures that people are going to want to see, and I know as you get even closer, they're going to want to see some of the really nice high-resolution stuff. So where can people go to be able to sort of watch the data come out of New Horizons, live, and be able to start looking over the images and kind of getting excited by what you're finding?
Well, I think each of us can chip into that, but let me say that there are 4 places you can go. You can go to your television, because it's going to be on NASA television, which many cable and satellite channel distribution systems have. You can go to your computer and find lots of ways through the internet to watch it. You can go to any NASA center, like Johnson Space Center, Kennedy Space Center, Goddard Space Flight Center, Jet Propulsion Lab, and all the rest, and they'll all be hosting events at the flyby in the middle of July. And finally, you can go to any one of what are going to be hundreds. In fact, you can even throw your own party called a Pluto Palooza. If you go to our website, if you just Google Pluto New Horizons and find our website, you can get a Pluto Palooza kit to throw a party at flyby at your home, at your church, at your astronomy club, where you work, anywhere you like. And so there are lots of ways and lots of places to go. A lot of the things on the internet have to do with social media, also websites and YouTube and television channels. Maybe we'll just start with Kelsey and let each person chip in one of their favorites.
Sure.
And by Googling Pluto New Horizons, all of your viewers can find even more than these. But we can help you a little bit here at the end. Kelsey?
Sure. I would say one of my favorites is the Pluto picture of the day. It's similar to the astronomy picture of the day, but specific to Pluto. And you can find that by Googling it as well.
Right. Another one is a planetary photojournal site, which goes into a little bit more detail than some of the press release pictures. And again, Google is your friend.
I would just say Google the NASA Pluto New Horizons, and you'll get a lot of good current information on the mission.
Kathy?
And I would say that the APL Pluto site is an excellent place to go. It's pluto.jhupl.edu. Thank you. and so,
my browser just knows
my
it.
browser finishes it for me. And that's a great place to go to see all sorts of new news that's happening on the mission.
Alex?
So I keep an active list of all the science team members that I'm aware of that are on Twitter. So if you'd like to see us, we're going to be pretty swamped and probably not like super crazy busy on social media during the actual flyby. But I'm sure we'll have some things to say, and we'll be talking about what it's like to be there, kind of on the ground. So you can find that list. I think at least half of us on this call are on Twitter and talk about the mission there. So you can find, there are a couple official and semi-official New Horizons Twitter streams. Alan is at Alan Stern. I'm at Alex_Parker. Kelsey here is at Gummy Shark. Kathy is Colkin. And you can find those on the New Horizons Science Team Twitter list. So that's a good place to start if you wanted to follow the individual scientists and engineers on the team.
And Fraser, I'll just say a couple more things for everybody. There are 4 television specials being made to be aired the week of the flyby by NHK in Japan, by Discover Channel, by PBS Nova, and by National Geographic. And I also have this very old issue of National Geographic from 1970. It talks about the future exploration of all the planets, including Pluto. And it's really just a prop for me to say that this month, if you go to a newsstand, an old-fashioned newsstand, you can find on the cover of Astronomy Magazine, New Horizons, the cover of Sky and Telescope, on the cover of Nature, on the cover of New Scientist, the cover of National Geographic, in fact. So there are lots and lots of resources that are out there. There's almost any information delivery system that you want.
Well, once again, we're out of time, but thank you so much for being able to spend the hour with us and give the update. I apologize to all the people who asked questions. There are literally hundreds of questions that I saw on the list, and so I pulled as many as I could and merged them together. But but the enthusiasm and excitement is getting pretty high. So I think I want to leave one thing in everyone's brains as we leave, and let's give them that date again, so they make absolutely sure that their calendar. Alan, what is the date?
July 14th, Bastille Day, Tuesday the 14th, 25 days from today.
Fantastic. All right. Well, thank you, everyone, and thanks for sticking with us. And I hope we'll do this again. But if not, we'll see you all on July 14th.
Bye.
Thanks.
Thank you.
Bye-bye. Thanks, Fraser. I don't know if you can hear us. Hey, everybody did good.